Okay, so we're going to work our way through the selected CBA questions on this paper one from November 21. You can see here the questions that we'll go through. So questions 1 to 10, and then 13, 14 and 16. So question 1. This is the OCW question. The sizes of the angles A and B in the triangle shown below are in the ratio of 2 to 3. Calculate the size of each of the angles A and B. You must show all your working. Okay, so we know that in a triangle the angles add up to 180. So we'll write that down because we're in this communication question. So A and B must add to 180 less the 25 we know, so 155 degrees. And we know that the ratio of A to B is 2 to 3. So that 155 we need to divide into 5 equal parts. By adding the ratios together. So each of those will be 5 into 155. 5 into 1 doesn't go, 5 into 15 goes 3, 5 into 5 goes once. So each part will be 31 degrees. So that will be 31 times 2 equals 62 degrees. And B will be 31 times 3, which will be 93 degrees. So marks for that, you'll have a method mark for working out the ratio. There'll be one mark for knowing that you're working with 155 degrees, and an answer mark for the two angles. And then the OCW will be for just making it clear what you're doing in the different stages and consistently when you're working with angles using the units degrees. Question 2. Find the lowest common multiple of 60 and 72. Now there's different ways that you can do this. The one consistent method is and you can use it for the highest common factor as well as the lowest common multiple, but it is a little bit more work, is to use the Venn diagram method. So I'll show you that. So the first thing you do is you need to break each of these down into their prime factors. So start with 60, repeatedly divide by prime. It's even, so we can divide by 2. 2 goes into 60 30 times. 2 goes into 30 15 times. 2 doesn't go into that, so we'll try the next prime, which is 3. 3 does go into 15 5 times, and 5 goes into 5 once. So you keep dividing until you bring it down to 1. So 60 is 2 times 2 times 3 times 5. We then do the same for 72. 2 into 72 goes 36. 2 into 36 goes 18. 2 into 18 goes 9. 3 into 9 goes 3. 3 into 3 goes once. So 72 is 2 times 2 times 2 times 3 times 3. So once you've broken it down into its prime factors, you then draw a Venn diagram. And within that Venn diagram, you've got the circle to represent the factors of 60 and the circle to represent the factors of 72. And in the center, you put the factors that are repeated in both. So I've got, if I just change color, I've got a 2 repeated. I've got another 2 which is repeated. I haven't got another 2 that's repeated, so that one stays there. I've got a 3 which is repeated, and I haven't got anything else that's repeated. So what's left in the 60 then is a 5, so that goes in that part of the Venn diagram. So that's dealt with. And then in this one we've got a 2 and a 3. If you wanted to work out the highest common factor, which we don't, the highest common factor is what we get by multiplying the numbers in the overlap. So HCF, if it was asked for, would be 2 times 2 times 3. So not required in this case. The LCM we get by multiplying all of those digits that are in pink. So 5 times 2 times 2 times 3 times 2 times 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 5 2s are 10, 10 2s are 20, 23s are 60. 60 times 2 is 120. 120 lots of 3 is 360. So the lowest common multiple is 360. Now that method will work every single time a question asks you to do LCM or HCF. So it's a method that, yes, it's a bit more time consuming in this case than maybe writing out your 60 times table and your 72 times table until you come to the first digit that corresponds. But it's not that time consuming. So you got a method and an answer mark for that. Express 882 as a product of its prime factors. Well, we've just practiced that in part A. So 882, it's even. So I'm going to divide by 2. 441. Right, 441 isn't even, but I think 3 goes into it. So 3 into 4 goes once, remainder 1. 3 into 14 goes 4 times. 4 3s are 12, remainder 2. 3 into 21 goes 7 times. I know that 3 goes into that as well. So 3 into 14 goes twice. Remainder 2. Hang on, what have I done wrong here? Three into 14 goes 4 times. Remainder 2. 3 into 27 goes 9 times. And then 7 goes into 49 7 times. 7 goes into 7 once. Stop. So that's your method. If you just to write 882 equals 2 times 3 times 3 times 7 times 7, that would get you a mark, but it wouldn't get you the final mark because the instruction here is in index form, which will be 2 times 3 squared times 7 squared. You could put 2 to the power of 1. That would be just as correct. Question 3. Complete the table below. Draw the graph of y equals 7 minus x squared for values of x between minus 2 and 4. So when we practice these, I've been encouraging you to plot the points that you're given to get a sense of what values of y the missing coordinates are before you work them out. So we've got minus 2 and 3. Minus 2 straightforward. Now 3 on this, we're going from 0 to 5 in 10 squares. Each little square is a half a unit, or 2 squares would be 1 unit. So minus 2, 3 will be there. Minus 1 we don't know. 0, 7 will be there. Halfway between 5 and 10 is 7.5, so it's 1 square below. 1, 6, 2, 3, 3 we don't know, 4 is minus 9. So all of the other graphs that we've been drawing as we've been practicing have looked like that. This one clearly doesn't look like that, it looks like this, and that's perfectly correct because this time our x squared part of the expression that we're working with is being subtracted. So that's what we're looking for. So my minus 1, I'm looking for something probably around 6. And my value for 3 is probably going to be about minus 2, maybe even 0. We'll see. So first one then, minus 1. So x equals minus 1. Y will be 7 take away, and then where the x is, we break it into a bracket, minus 1 squared. Minus 1 squared means minus 1 times minus 1. 1 is 1, minus times minus is a plus. So that becomes 7 take away 1, which is 6, which is kind of what we were anticipating. So I'm happy with that. X equals 3, y equals 7 take away 3 squared will be 7 take away 9, which is minus 3. So 3 minus 3 is there. So we've got 1 mark for 6, 1 mark for minus 3. We then got to draw our graph. Freehand. We don't have to turn the page upside down this time because the curve is an upside down version of what we normally have. So that's the curve. You can see the points we've plotted clearly, and then a freehand curve connecting them. So there's a P1 for plotting the points and a C1 for the smooth curve. Question 4. Calculate the total perimeter of a semicircle of radius 4 centimeters. Now the formulas for areas and circumferences of circles aren't given to you. You need to know them. So if you've got a circle with a radius, then the area, which we're not going to use, but just to remind you, is pi r squared. The circumference is pi times the diameter, or 2 lots of the radius. Now we're working with a semicircle, so if we first work out the area, the circumference of the circle, it's a non-calculator paper, and they're telling us to use pi is 3.14. So circumf of circle will be pi times 2 lots of the radius, which is 8. So it's a non-calculated paper, so down here I'm going to do 3.14 times 8. 4 8s are 32, 1 8's 8, 9 10 11, 3 8s are 24, so it's 2512. You need to know where to put the decimal point. Count the digits after the decimal point in the starting numbers, 2, so it's going to be 2 after that. The other thing you could do is just estimate 3 times 8 is 24. It's not going to be far off that. So that's going to be 25.12. We haven't got a full circle though, we've got a semicircle. So circumf of semicircle will be 25.12 divided by 2. 2 into 2 goes once, 2 into 5 goes twice, remainder 1. 2 into 11 goes 5, remainder 1. 2 into 12 goes 6. So the circumference of the semicircle is 12.56, but we're looking for the perimeter. Now the perimeter of the semicircle will be the distance you travel if you start at one end, walk along that part of it, which we've worked out is 12.56. Then we've got to get back to the start, which is an additional 8. So the perimeter will be 12.56 plus 8 equals 20.56 centimeters. So 3 marks for that. There'll be 1 mark for working without the circumference of the semicircle, and an answer mark for 12.56, and then a final answer mark for adding, remembering to add on the additional 8 centimetres. Question 5. Part B, we're not going to spend any time on. We haven't covered any work on that. Rearrange the following formula to make k the subject. So we use the rules of equations to do this. So the first thing I need to do to get the 3k on its own is take off 2. If I take off 2 from that side, I have to do the same to the other side. So I get p take away 2 equals 3k. The 3 and the k are joined by multiplication, so to undo a times 3 I have to divide by 3. Got to do the same on that side as well, and that will leave me k equals p minus 2, and when we divide by 3 in algebra we put it all over 3. So there'll be 1 mark there for getting p minus 2 equals 3k, and the second mark for dividing by 3. Question 6 is standard form. So we need to get this as a number digit between 1 and 10, which will be 5.8. And then if I just make a bit more space, so my decimal point is there, 10 to the 0 will be that side, 10 to the 1, 10 squared, and so on. This side of the decimal point, 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, 10 to the minus 4, and so on. My number is 0.0058. You look at the most significant, which is 5 times 10 to the minus 3. So this will be 5.8 times 10 to the minus 3. If you don't want to write that out, then you've just got to remember that's okay. So that's 10 to the minus 1, 10 to the minus 2, 10 to the minus 3. Right, when we multiply or divide, we deal with each part separately. We deal with the number part, so 1.4 divided by 2, and then the power part, when we're dividing bases that are the same, so this is indice work, which we've done quite a bit of practice on, we subtract the powers. So that will be 10 to the minus 3. 1.4 divided by 2 is 0.7 times 10 to the 9 take away 3, which is 6. Now the problem is that isn't in standard form, because that's not between 1 and 10. This in standard form, if you think there, it's going to be 0.7, so it would be 7 times 10 to the minus 1 times 10 to the 6. When we multiply the bases, we add their powers. So that would become 7 times minus 1 plus 6, 10 to the 5. So there'll be 1 mark if you got 0.7 times 10 to the 6. Second mark if you then correctly put that in standard form. Question 7. A group of people have put their names forward to carry the Welsh flag at a sporting event. Each person lives in North Wales, Branch, Mid Wales or South Wales. The probability, one person from the group is chosen at random. The probability of choosing a person who lives in North Wales is 0.3, Mid Wales 0.25, and the probability of choosing a person who is under 18 is 0.2. The people's ages are independent of where they live. It doesn't have any difference where they live as to their age. Complete the tree diagram shown below. So we've got 3 marks here. The branches need to add up to 1. So I've got 0.3, 0.55, 0.45. So that's the first event, where they live. And then the second event is how old they are. Under 18 is 0.2. So these branches have to add up to 1, which means that will be 0.8. There's 1 mark if you've got the 0.45 there. There's 1 mark if you correctly complete 1 pair of branches here, and then the third mark would be for transferring that down through the other sections of the tree. What is the probability of choosing a person who lives in South Wales and is under 18? So South Wales is that single branch, and is under 18 is that branch. If you're moving in the same direction along a probability tree, and you're using the word and, which you will be, you multiply the probabilities together. If you need to go back to the start and you find yourself using or, so what's the probability of them being under 18 from South Wales or from Mid Wales? You do that times that plus that times that, because you're going back to the start to take a different route. Now 0.45 times 2 is going to be 90, or 2 times 45 is 90, so that's going to be 0.9, but it's not 0.9 because that would be doubling that. Sorry, I've gone blank then for a minute. 0.45 times 2 would be 0.9. 0.45 times 0.2 is 0.09. 1 mark for the maths, writing down 0.45 times 0.2. 1 mark for correctly getting 0.09. Question 8. Diagram below shows an isosceles triangle and a square. So it's an isosceles triangle, which means two of the sides are the same, indicated there and there. This side is 2x, that side is 3y, that means that side must be 2x as well. And we know that the perimeter, if we add all those together, we're going to get 19. And then for the square, I know that that side is 12, and because squares all the sides are the same, it means that that must equal 12. Use an algebraic method, not trial and improvement, to find the value of x and the value of y. So we've got two unknowns, x and y. That means we need to have two equations. From this triangle, I've got 2x plus 2x, which is 4x plus 3y, must equal 19. I call that equation 1. And from this shape, I know that 6x minus y must equal 12. So this is a simultaneous equation question. We've gone through a few of these in the past papers, and we practiced them when I was off with COVID before Easter. So the method you need to employ, there are lots of different ways of going about solving simultaneous equations, but what I've tried to do is just give you one method that you can apply every time rather than get confused with different methods. You want to make the x's the same. In order to make the x's the same, you take the number that's in front of the x in equation 2 and multiply equation 1 by it. So equation 1 we're going to multiply by 6. So 4 times 6, 24. 3 times 6, 18. So 4 6 is 24, 3 6 is 18, 19 times 6, not sure, just do it over here. Remember, non-calculator paper. 9 6s are 54, 1 6 is 6, so that's going to be 114. And we call that equation 3. Then the point is, I want to make the x terms the same, so I now take the second equation and multiply it by the number that's in front of the first x. So I can times it by 4. That gives me the 24x that I'm looking for. Minus 4y equals 48. So that's been multiplied by 4, that's been multiplied by 4, and that's been multiplied by 4. Because what I'm trying to do here is get rid, or end up with an equation with just the one unknown. And that will come now, because what I'm going to do is do equation 3 take away equation 4. So 24x take away 24x has gone. You need to be careful here because you're doing 18y, that should be, take away 4y. Okay? 18y take away, sorry, minus 4y. 24x take away 24x. 18y take away minus 4y, and then 114 take away 48. So 18y take away minus 4y is the same as 18y minus minus makes it plus. So you end up with 22y, and then 114 take away 48. So we need to borrow from there, and we end up with 66. To get the y on its own, we have to undo a times 22, which means we've got to divide by 22, and that will leave us y equals 3. So we now know that y is 3. What we then have to do is work out what the x value is, and we do that by replacing in one of our equations, and we'll go for equation 1, substitute in 1, so 4x plus, and then instead of y, I'm replacing it with 3, equals 19. So 4x plus 9 equals 19. Take 9 off each side, and I get 4x equals 10. So x will be 10 divided by 4 each side. 10 divided by 4 is 2.5. So x is 2.5, y is 3. Now that looks like a lot of algebra. It is a lot of algebra, but as something to revise, it's really quick. You've just got to practice that whole equation times 6, that whole equation times 4. Take them away. Be careful when you're subtracting a negative value. It becomes a plus. Solve your equation. Take that value and replace it in the first equation, and then solve that second one. So with this, you're going to have 1 mark for setting up your simultaneous equations. You're going to have a method mark and an answer mark for getting rid of one variable, x in our case, and solving for a, and then 1 mark and an answer mark for finding the second value. Question 9. Describe fully the single transformation that transforms shape A onto shape B. 3 marks, higher tier paper. We're in the second half of the higher tier paper now, so this is the grade A question. What's happened to triangle A? Well, it's become smaller, so that means it's an enlargement. What's happened? How has it been made smaller? Well, it's half the size. But this is, if it was just a scale factor of a half, it would be the same way up as it was in the original. Because this has been inverted as well, it's that A grade transformation, which is the negative one. So it's an enlargement with a scale factor of minus a half. So we've got 1 mark for recognizing it's an enlargement. We've got 1 mark for saying its scale factor is minus a half. The last mark is for saying where the center is. And we'll find that out by joining the corresponding sides together. So the top of the triangle ends up there. This side of the triangle has been rotated to there, and this side ends up there. And where those orange lines intersect, there, that's our center. and we give it as a coordinate. So the coordinate is 1, 0. So 3 marks for that. You want to be looking for that. It's coming up. Question 10, algebraic fractions. This was our kiss and smile method that we enjoyed, where we take that and we multiply by that, and we multiply by that, and we put it over the product of the 2 on the bottom. So 5x bracket 4x plus 3 minus, because it's a minus, could be plus, 4x bracket 2x minus 1 all over 2x minus 1 4x plus 3. Okay, we don't expand the brackets at the bottom, that's as neat as they get, but we do expand the brackets on the top. So we get 5x times 4x, 20x squared, 5x times 3, 15x, 4x times 2x, 8x squared. Mindful of the sign, that's negative, that's positive, answer's negative. 4x times 1, 4x, negative times a negative, signs are the same, answer is positive. All over, double bracket. Okay, we can simplify the top. So we've got 20x squared, take away 8x squared is 12x squared. 15 plus 4x is 19x, all over 2x minus 1, 4x plus 3. The only thing left that we can do to simplify that further is we can take an x out as a common factor on the top part of that fraction. So we have x bracket 12x plus 19 all over 2x minus 1, 4x plus 3. So there's a method mark for kiss and smile. There's an answer mark for correctly getting rid of all the brackets. There's an answer mark for simplifying the top line. And finally, the fourth mark is for spotting you can take out x as a factor at the end. Question 11 we haven't covered. Question 12 we haven't covered. Question 13. Okay, so I've got a quadratic equation. I've got an x squared term, I've got an x term and a number. If it helps, put the number 1 in front of the x. You must use an algebraic method and show all your work in. It's not going to be one where we're going to be using the quadratic equation formula there. That's a paper 2 question, and the clue will be, it'll say giving your answer to so many decimal places. This could have just been a factorised question. If it was just factorise 4x squared minus 1x minus 3, the first few lines we're going to do would be exactly the same. So the method you have to remember that I taught you was you take the number in front of the x squared and the number that's on its own and multiply them together. So we do that times that and we get minus 12. We then list the factor pairs of 12. So 1 and 12, 2 and 6, 3 and 4. The next one will be 4 and 3, just to repeat. And then we choose a combination of those. Which pair can we make add up to minus 1? Well, there's nothing we can do to 1 and 12 or 2 and 6. It's got to be 3 and 4. And we want to make minus 1, so we need to have a plus 3 and a minus 4. We then rewrite that, but instead of having minus 1x, we're going to write it as plus 3x minus 4x and then minus 3 that we're given there. We ignore the second part and we look to factorize the first pair. So I can see I can only take out an x. There's no numbers I can take out, leaving me 4x plus 3. We then move on to the second pair, and this bracket bit has to be the same. So what can I take out of there? Well, the only thing I can take out is 1. 1 times 4 is 4, 1 times 3 is 3. But I need not to have plus 4x and plus 3, I need to make them minus. So minus 1 times 4x will give me that, minus 1 times 3 will give me that. That then means that I've got this repeated 4x plus 3, and if I take that out, it leaves me x minus 1. So if the question was factorize 4x squared minus x minus 3, that's your answer. But this is equal to 0. So this is where we say, well, either we're going to have to choose the value of x which will make this 0 and work out what that is, or that one. And we need to do both. We can't just choose. We need to show there are two different values. So we say either 4x plus 3 must equal 0, so that must be 0, because if that's 0, 0 times anything there would be 0. Take 3 off each side, divide by 4. Okay, so that's just, I'm saying rather than writing everything down. Take 3 off there, you take 3 off there. 0 take away 3 is minus 3. To get the x on its own, I have to divide by 4, which will make that 1, and then I have to divide that by 4 as well. So either x equals minus 3/4, or x minus 1 must equal 0, add 1, or x equals 1. So the solution is either x equals minus 3/4 or x equals 1. So you're going to have a method mark for factorizing, an answer mark for correctly factorizing the two brackets, and an answer mark for your two finished solutions. Question 14 is the last but one. So question 14, indices. Everything that's in that power is a little message for you. Okay, so we've spoken about this. If it's minus, that means reciprocal. That means 1 over the value. If there's a fraction, the number on the bottom of the fraction tells you it's the root, so it's a square root because it's 2. The number on the top gives you the power. So those three messages are what we're going to do to the number 4. So first of all, it's 1 over. Then it's 1 over the square root of 4, which gives you that bit. And then that's going to be cubed. So minus means 1 over, square root of 4 cubed. Square root of 4 is 2. When you're square rooting, it's what number times itself gives you that. It's the opposite of squaring. So that would be 1 over 2 cubed. When you're cubing, you're multiplying by itself 3 times. 2 times 2 is 4, times 2 is 8. So the answer is 1 over 8. So you're going to have 1 mark for the 1 over and 1 mark for the 8. Part B, evaluate 1/3 plus 0.02 dot. So we've got a recurring decimal here that we need to turn into a fraction. So the method for that is you let x equal 0.02222 and so on. Then if we multiply that by 10 to get just the repeating part after the decimal point. Sometimes you can subtract now and it will get rid of the recurring part, but it doesn't in this case because the first 2 digits after the decimal point don't line up. So I need to multiply it by 100, and that will mean I'll get the 2.2222 and so on. So now these do align. So if I subtract, I'm going to get 100x take away 10x is 90x, 2 take away 0, and then all of those are going to disappear off and cancel out. So 90x is 2, divide by 90, and I get 2 over 90. 2 over 90 is the same as 1 over 45. Now it's not asking you to simplify this, so that is a fraction. So we need to work out what 1/3 plus 0.02 recurring is, which means we've got that. Now that's a fraction, and just like the algebraic fraction we did, kiss and smile works here as well. So the easiest way to work this out is going to be the kissy bit, so 1 times 90 plus 2 times 3 all over 3 times 90. So it's exactly the same as we were doing with the fraction, the algebraic fraction. That times that plus that times that over that times that. So that's going to be 90 plus 6 over 3 9s, 270. So we've got 1 mark for the method of dealing with a recurring fraction, recurring decimal, and 1 mark for getting 2 out of 90, and then the 3rd mark will be for then adding a 3rd to it. Question 15, haven't done. Question 16, more indices and surds. You are given that C is the square root of 18, D is the square root of 12, and E is the square root of 3. So we want to rewrite C is equal to the square root of 18 in its simplest terms. To do this, and if you look in your notes when we did surds, lots of practice of this, we want to write that 18 as a factor pair where one of the numbers is a square number. So 9 times 2. 9 2s are 18, 9 is a square number. That means that I can work out what the square root of 9 is. Rules of surds, I can write that as that. So the square root of 9 times 2 is the same as the square root of 9 times the square root of 2. The square root of 9 is 3, because 3 times 3 is 9. So I'm looking for 3 root 2. D over E is the square root of 12 over the square root of 3. That's the same, in the same way as we did with multiplication, the rule applies here as well. The square root of 12 divided by the square root of 3 is the same as the square root of 12 divided by 3, which is the square root of 4, which is 2, because 2 times 2 is 4. E to the 5 is equal to, well, e to the 5 means e times itself 5 times. So that's going to be root 3 times root 3 times root 3 times root 3 times root 3. Now when you times a square root by itself, it just becomes 3. So that's going to be 3 times 3 times root 3. We've got that one left at the end that hasn't got another root 3 to work out. So this becomes 3 times 3 is 9 root 3. So 3 marks there, 1 for each. Now as surds questions go, that's not bad. That's just basic practice of the earliest work that we did on indices and surds. So if you go back and look at that, those marks are accessible. It's question 16, it's AA star work, but it's AA star work that you're capable of doing.